Why do we need to craft a tech stack? What's really going to happen? What's the risk?
I'm going to start with something slightly controversial and possibly slightly boring to a lot of technologists. You could be very excited that an algorithm produces the kind of insights that you wanted to, but that's not the win. Deliver that 5% increment of uptime, and that translates into a $200 million benefit for the business. That $200 million benefit is what's going to fund your start of the AI journey.
If you're using GenAI, then you have to obviously factor in a whole load more of data than what you think that you want.
A lot of enterprises have legacy infrastructure that is not really geared to deal with the current age of AI applications.
The enterprise stack, how do you break it into different layers? How do you look at it? How would you recommend that folks approach this?
I think we're going to see a massive explosion in how data gets to be managed. If you don't know what problem you're going to solve for and how much of an improvement you're going to deliver, you don't know what value the business is going to get out of it.
Classical AI versus Gen AI. Does anything change in this layer?
In the energy industry, they would obviously say, hey, we are all about processing liquid gold. Your models will essentially be processing digital gold, which is your data. It feels like the first day for sure for Rajini movie, right? It's like, I've got everything ready. I just need to actually see தலைவர் in action.
Absolutely. So why don't you dive right into it? That's exactly the next question that we had. Please demystify this for us. Welcome to the Neural Talks, your gateway to the forefront of AI innovation. I'm your host, Ranjit Malarkot, and together we'll explore the AI revolution with the brightest minds pushing boundaries and shaping the future. Through candid conversations, they share hard-won insights as we unlock the transformative power of AI. Get informed, get inspired. This is the future, and you're in the front row. Welcome to another edition of the Neural Talks. This week, we have with us Hariharasudhan Ramani, Head of Digital Innovation at a Fortune 10 global energy major. He's here to talk to you on a very, very exciting and pertinent topic. If you're an enterprise looking to get onto the AI bandwagon, AI enable your products, you need to start with an enterprise AI tech stack. So Hari and I are going to be chatting about crafting an enterprise AI tech stack and the best practices for doing this. Hari, superb to have you here. Welcome to the Neural Talks.
Thank you so much, Ranjit. It's always a pleasure to actually come back here. Been inspired by the work that you and the team at the Neural actually go about doing to educate enterprises, and happy to play a small part in it. I've got a bit of background in this space. I've been doing corporate strategy for the early part of my career, but the last decade or so, I've been focused on doing enterprise AI, both deployment as well as transformation. And it's been a fascinating journey. Too often, enterprises don't think about the technology stack. They get enamored by the hype and the reality of AI. But what they don't understand is some of the dull, boring technology stuff that goes behind the scenes is, if not more, possibly equally important in getting your AI journey right. We're going to try and actually focus a bit of that in today's conversation.
Super. You've been at the forefront of digital innovation, AI deployments, at different types of scale and, spanning this global enterprise that you're part of. Before we dive in, could you tell us a little bit about your journey and experience with AI in specific, please?
Yeah, I mean, sitting here, having done quite a bit in the AI space, it's possibly easier to say everything is rosy and everything's fantastic. But if I just look back upon my journey, I mean, the journey that I've been along with my team members, it's literally sort of material for a book on what not to do. I mean, literally every mistake there is to do in the space, we've actually made it. And it's a series of those mistakes, but more importantly, the willingness to learn from those mistakes that helped us, right? I mean, think about it. We tried to do everything by ourselves when we didn't have to. We didn't manage the whole problem into smaller pieces and then go after the right ones. We actually tried to do it all. And even when we tried to actually break it down into smaller chunks, we actually went after the wrong chunks. We started developing solutions on back in the day, a solution stack called R, which is literally a statistical programming language, very powerful one at that. And then we had a couple of powerful computers with 48 cores, and we started writing programs. And for the purposes of our algorithmic development, we started using highly curated data, which was rid of all sorts of problems in quality, in volatility, and all of that stuff, right? So it was the perfect data, it was the perfect algorithm, and when we got the results, we were super excited. And Imagine our surprise and shock when we tried to deploy it, not even on a production environment, on a real-time data, it came completely crashing down. Nothing worked. It wouldn't run. It wouldn't give insights at the time intervals that the business wanted. This was an early stage treasury forecasting solution. The traders needed the data first thing in the morning, and we would actually give it somewhere around 2:30 in the afternoon when most of the trades were already done because the algorithm just took forever. There were a lot of things that we've actually gotten wrong on this journey. But what is very, very important is that we learn from each of these mistakes, or at least most of the mistakes. And it all goes back to one fundamental thing. AI is technology. And as technologists, we get very excited with new age technology. But it's important to make sure that the purpose of that technology is to address business requirements. Go back to what the business goals are. Go back to what really constitutes a win. You could be very excited that an algorithm produces the kind of insights that you want it to, but that's not the win. The real win is when those real insights from the algorithm are handed to the right person in the business who then takes the decision that delivers the business value. And when the business value is delivered, that's the win.
Perfect. So you're saying, focus on the value of the problem that you're actually trying to deliver. So, why do we need to, craft a tech stack? Why is it so important? Because is it really okay for businesses to just or enterprises to do this, run away and just start building today and deploying today without paying attention to this?
I'm going to start with something slightly controversial and possibly slightly boring to a lot of technologists that are going to tune into it. When you want to start writing the constituents of your tech stack, it's actually not the technology that you start with first. Look, most businesses today are already sold on the hype of Gen AI. On a daily basis, you have more and more news coming out on the advancements that AI and Gen AI are making, that businesses are already looking at AI as a bit of a panacea for all of their problems, all of their issues, right? Um, and they've already sunk in a lot of money on their existing tech stack. So if you're an enterprise and you're being told by your CEO that you need to get on the AI journey to build that competitive differentiator, or at least to make sure you catch up, you're looking at your current tech stack and you're going, there's no way I'm going to be able to actually add AI on top of this, let alone Gen AI. And that's usually where the challenge is, right? You need to start not on technology, but on what the business goals and business values are. Don't worry, we're going to talk about technology and we'll address that in a bit more detail. But start from the fact that a lot of enterprises have legacy infrastructure that is not really geared to deal with the current age of AI applications, which means everything that you do to deliver AI at scale for your enterprise is going to cost money. And when you go back with a big fat bill to your CEO and say, this is what it's going to take for me to deploy AI use cases that you want, it's got to be a number that they are sure they can afford. But how do you even come to that affordability? And that's one of the things that you need to start to reconstruct, because that affordability is driven by what value businesses can actually get from AI. And that's the starting point of crafting the tech stack for your organization.
So I think we're sort of going counter the flow, for our tech podcast. We're saying that this is a tech podcast. We're talking about enterprise AI stacks, but hey, we're starting with business. I mean, so for our tech audiences, as Hari said, this may seem counterintuitive, but I mean, this comes from a lot of experience and comes from a lot of failures. And Hari's been one that actually shares this with us in many ways. So start with the business. So, to sort of double click on that, Hari. So, you said start with the business goals in mind, start with the value that you're actually delivering. But what's the process just after that? I mean, how can one sort of start double clicking down that and build it up and blow it up a little bit? Could you help us with that?
Yeah, absolutely. We tend to think of business as a bit of a homogeneous entity, right? But every organization will have its core business, whether you're in manufacturing or you're in services, you'll have a core business, and then you have a whole bunch of functions. Start with the business outcomes that you really, really want to go after. For example, if you're in manufacturing, some of the biggest pain points in manufacturing today are the cost of your operations, the cost at which you run your factories. How do you get your factories to be up and running with minimum amount of failures, with minimum amount of downtime, and maximum amount of efficiency? If that's the outcome that you want to go after, then try and kind of understand that problem statement in a lot more detail, and then get to it and set some realistic goals to say, today I operate at 90% uptime. If I push myself to 95% uptime, this is the value in dollar terms. That's an easy calculation to make. And why is this important? If you don't know what problem you're going to solve for and how much of an improvement you're going to deliver, you don't know what value the business is going to get out of it. And that value is what's going to fund the bill for your AI journey. Let's say you
Absolutely.
actually deliver that 5% increment of uptime, and that translates into a $200 million benefit for the business. That $200 million benefit is what's going to fund your start of the AI journey. Then go after every other problem, whether it's in HR, where there's an efficiency improvement, or finance, where there's automation benefits. You start kind of tackling all of the use cases, but go after the ones that give you the most priority, and then start unpacking it. Now, what you would have done by this time is create a big picture of where all AI can actually have an impact on the organization, a range of use cases that you can go after, and it will give you an idea of the scale at which you need to deploy this across the organization. When you start with solving a particular problem, you would typically think of, I need to solve, for example, let's take predicting that failure in that manufacturing environment, right? You would go, I just need to predict that one equipment's failure so that I can show the art of the possible. Absolutely spot on. As a technologist, we love it. But if you have 20,000 equipments and you have to run this for 20,000 equipments, you suddenly go, oh, wait, I need a tech stack that can actually support all of that. If you have each of these equipments with 10 sensors and they're all providing data on a 10-second basis, just compute the number of data points that you have to compute through to produce a failure prediction algorithm that will be accurate enough. You suddenly start to get the scale that you're actually dabbling with. Now, then you get to, hold on, if I deploy technology infrastructure to meet that problem, my business will never be able to afford it. Then you start to scale it down. It's like, I can get only $200 million, which means I can spend about 10% of that, $20 million on a tech stack. What do I really do to push it? Now, it starts to give you that business value that you get, and it starts to give you the confines of the affordability. But it also starts to educate you on how much of this needs to be real time, how many equipments really need to be monitored, how accurate should the prediction be, and a lot of those pointers will tell you what kind of tech stack you need to craft. So I would say start from the business value, understand what are the use cases in the big picture that you need to solve for, and then start crafting your journey in a roadmap with milestones that will let you get to it.
So I think so. What you're saying is, I mean, what we've covered so far is start with the actual business value that the AI is going to be delivering to the business, not in terms of technology. Start with then the business outcomes that you're actually focusing on. And then once you know what business outcomes, figure out what is the scale in which you want to deploy for these business outcomes, right? I mean, do you want to deploy for one office or one branch or for one product, or you want to deploy it for the entire range? You want to go global, you want to go deep, or you want to go broad? And then you're saying, depending on on the scale and the business outcomes, now double click, make a bunch of milestones, make sure you have clarity in terms of what all needs to get delivered, and also get a sense of how the interconnectedness of those systems is actually behaving. But I'm going to just sort of, take a sort of tangential view, right, and sort of come at it from a slightly different angle now. Now, we have two forms of AI. One is the classical AI, which the slightly older generations are actually used to. I'm bracketing myself there. And so you have this NLP, you have these prediction models, classification. These were the non-glamorous applications of AI, but still they produce they lifted their weight and they produce a lot of output. And now the more recent, in the last 5 years, we have transformers, and then we have Gen AI, and then we have, diffusion models. We have all kinds of other models that's coming out. So Gen AI is a different class of applications. So now when you have classical AI applications and you have Gen AI applications, now does this flow or these steps, do they change in any way? Are there any new dimensions that are being added?
This is always a very, very interesting question, right? So first of all, I put myself in the same bracket as you do yourself, Ranjan. I still stick to the classical AI because for the last 11 years, that's what's delivered massive value in my career, right? So I'm going to stick to that. And I'm not by any means trying to actually dismiss Gen AI as hype or new kid on the block. It is new kid on the block and it's got a significant amount of potential. But I really don't want to say one versus the other, right? It's much more of an evolution. When we started our journey, I just talked about manufacturing. So from my own experience, we started on a similar journey and we said, look, we're going to plan for the stars from an infrastructure standpoint. We've got operations in 25 plus countries. In each country, we have 3, 4 manufacturing facilities, and then we're going to start getting all of the data from there. And we said, look, we're going to need 5 to 10 billion rows of data, and that's what we're going to plan the infrastructure for. Because when we started putting first model, we actually built it. And the fact thing is, today, the infrastructure actually is perfectly capable of handling 1,000 times that much data. You heard that right? Now we can actually handle trillions of rows of data, and we're not breaking much of a sweat. And that's all kudos to the development in technology, compute power, data storage, and all of
That,
that.
that's a double click for another podcast. I'm guessing
Yes, yes,
it.
we'll get there at a different time, right? But the
Yeah.
infrastructure works. But the fun thing is, with the amount of data that Gen AI can consume, just your basic transformer models that can consume, it's going to blow anything that we've actually set up out of the water, right? Now, for the majority of us, we never are going to need that level of data storage. Why? Because we're not going to sit and develop our own LLMs. So,
Correct.
unless you're Google, Meta, or one of the big ones, Microsoft, that's developing these, you don't need that much data. You don't need that much compute power. In a lot of the use cases that's coming out of Gen AI today is about summarizing the information that's already found on our corporate knowledge store. And if Gen AI is going to be focused on those kinds of capabilities, you don't need that much compute. You just need to containerize your Gen AI application, make sure it reads all the data that's available within your enterprise, and then it gives you insights in a much more of a chat fashion. So think of Gen AI rather than general internet as reading data of your own enterprise. That's every data that you have available in your own enterprise, and then a generative AI model is going to read that. That's the most compute that you're going to need. So it's not like a significantly different ballgame for most enterprises. Don't get carried away by a lot of the news that you see outside. It's good to be informed, but it goes back to the same first principles that we've been talking about.
Got it. So what you're saying is Gen AI is different, no doubt. If you are actually in that few percentage in the world that's actually developing LLM models, pushing boundaries, and really trying to do something foundational, then yes, if you're using Gen AI, then you have to obviously factor in a whole load more of data than what you think that you want. So now double clicking on the enterprise AI tech stack, right? So now we spoke about, the value, the business outcome, scale, sort of then double clicking that and making that into different structured milestones. We spoke about AI versus, I mean, classical AI was Gen AI. The enterprise stack, how do you break it into different layers? How do you look at it? How would you recommend that folks approach this?
Yeah, I'm gonna start with maybe a little bit of how traditional IT departments have looked at their own infrastructure stack, right? So most of them have already made incredible investments in their existing tech stack. A big backbone of that is their transactional systems and databases. So you've got systems like SAP or Oracle that basically contain your entire ERP backbone, which includes majority of your supply chain data, your manufacturing data, your order management data, your customer database, your vendor database, all of that good stuff, right? Almost uniformly all enterprises have developed some form of data warehouses because they've realized that transactional systems, manufacturing systems don't necessarily cater to reporting needs because that was not the original intent behind them. You've actually pulled out all of the data and then you've set up some data warehouses that cater to your reporting requirements. But majority of these data warehouses are meant for data aggregation and inquiry. Again, reporting, right? Which means there's traditional databases. Now, some have made the leap towards columnar databases, and we'll come to that in a second. But you've traditionally had these for a very exclusive purpose of reporting, which means it aggregates the data, it helps you inquire, SQL queries, and all of that stuff. So it gives you that information. AI is a completely different ballgame. Because when you think of data warehouses, you would largely say, hey, I've got this manufacturing system. I need to have an understanding of what the history of failures is. You would write small sets of equations for calculating what's the mean time between failure or what's the mean time to repair. The MTBF and MTTR, those metrics, it's easy to calculate because they're simple mathematical operations. But if you want to run a prediction algorithm, you suddenly have to run it on all the sensors pointing to a particular equipment in your manufacturing environment. And you have to run about 6 or 7 different algorithms and possibly package them into an ensemble algorithm that will then give you a prediction that will say when that equipment's going to fail next. So the ball game is completely shifting in terms of where we're going. One is a test match, the other is a T20. And to kind of deconstruct that, I would typically first start with data storage layer. You've got your data sitting in multiple environments within your tech stack, whether it's transactional systems or operational systems. And some of them could also be computed capabilities or computed values sitting in your data warehouses. You pull all of that together and you go back to your first principles again. Only pick the data that you need for solving the business problem on hand. Now, the infrastructure should handle larger problems, but when you start, only go after the data you need. Don't try and solve for world hunger. Go after the small sets of data that you need. Now, even small here, remember the use cases I was talking about could run into millions, hundreds of millions of data that you need. And then you go into that space, pull the data together, and then start thinking about where all are you going to use the data. When you start thinking about AI applications, you then quickly need to jump into your compute layer because the compute will dictate how much data you're going to store. What do you mean by compute? You have to
So
run a
are
few
these two,
algorithms.
before you jump into that, Hari, are these, is the data layer and compute layer, are they sort of like bound together, or do you think that they should actually be independent of each other and each should be free of expansion of the other?
Yeah, it's a brilliant question and something we arrived at the answer through more trial and error rather than a very clear answer. Um, for us, one of the biggest principles, and we'll come to that principle a little later as well, is modularity. Each of the layers I'm about to talk about, Ranjit, is how do you make sure that you really keep each of them separate, allowing for them to kind of have the freedom to grow and kind of expand. And more importantly, have the flexibility to kind of swap out technologies if they evolve. So you've got a data storage layer where you get all the data, keep it ready for access, and make sure that you're able to kind of pull off of it whenever you need. Then you have your compute layer, which again, slightly independent. They're obviously connected. You need one to work for the other, right? But the next is the compute layer where you run your ML models, you actually have your pipeline, you make sure that you actually run a whole range of models in first training mode, then in validation mode, then you start thinking about deploying them into production mode. But ultimately, the deployment then goes into an application layer because that's where the end users are going to start integrating or kind of interfacing with the insights from the model, right? And then underpinning all of that is your governance layer. So you've got a data storage layer, you've got a compute layer, you've got an application layer, and then underpinning all of that, you have your governance layer. And that's how I would start thinking about kind of constructing the tech stack on what would enterprises need to learn large scale AI applications.
No, brilliant. I mean, very well broken down and very succinct. And so essentially, you're saying the first thing you said is data. The data needs for AI can be massively parallel depending on the scale of the business outcomes you're trying to drive. So warehouses are not the best solutions. You have to look for alternative solutions, and there are a plethora of them in the market. If you look at the performance of the use case, right? I mean, real time versus batch processing. Does this layer change, drastically, or these tenets remain the same? What are your thoughts?
Yeah. You, the audience is probably going to get sick of me referring back to first principles almost in every one of these questions. But there's a very important reason for that, right? For example, not every use case is going to need your platinum treatment, whether it is with top of
Perfect.
the shelf storage or compute or accuracy in models. You don't need that in every use case. Let's take that prediction example, right? Because that kind of helps us double click a little more. If I need to know when a compressor is going to fail, I really, really need to know within a very narrow window. I don't need a wide ranging window that says it's going to fail sometime in the next 3 months. I can't do anything with that, right? But if I know it's going to fail in 3 weeks from now, and that failure prediction is accurate, which it needs to be, we can start taking preventive measures on, hey, hold on, there's something wrong. Here is the reason why the application is telling me something's going to go wrong. So the accuracy is important. Now, in this particular use case, when it comes to prediction of a failure, accuracy is high, which means everything that works backwards from that point has to be top of the shelf. My models have to be super well trained. The data available has to be extensive. The compute layer that offers both the training and the deployment have to be really, really spot on. And the data needs to stream in real time. No questions. I can't really do batch processing in this space. So my business requirements will dictate how variable I keep my tech stack. There's no one size fits all. Let's be super clear on that. Do what is needed only based on the business requirements, and that will make sure that your affordability is kept in check. In that same example, the business would also like to have, and this is a nice to have, the reason for that failure. Now, they would love it if we can exactly say why it's going to failure, but they're perfectly happy if say, hey, the compressor is going to fail because of one of these three reasons, or most likely reason is going to be this. What's fascinating in this particular example is the same use case for the prediction, I need super high levels of accuracy, but for the reason ascribed to that failure is perfectly fine if I have a lot lower accuracy. And I don't even need it at the time when the failure indication comes in. I can get it a little later. So within that use case, for one insight, I need real-time data and I need very high levels of accuracy. But for another use case, it's perfectly fine if that comes a little later to say, on a batch processing mode, we think these are the possible failures. So the business will really dictate what kind of treatment you apply for any one of these attributes of how you craft your tech stack. One last thing, Ranjit, you will anyway need all of these attributes. And the common mistake that I've done in the past is I'm anyway going to need real-time data. I'm anyway going to need for top of the shelf accuracy. And I crafted my whole tech stack according to that. And guess what? The end of the month bill that I actually stuck about my CEO's desk did not make him or her happy. So always think about what the business is going to need from an affordability standpoint.
Totally. But whether it's high reliability, high performance, low performance, fast moving data, slow moving data, I think one needs to pay attention to the use case and make sure that they cover all layers of the stack for that particular use case, and then make sure that
Spot on.
the outcome is actually threaded across all these layers. Now, I'm thinking that now that we actually spend some time on putting up all the stacks, putting up all the layers of the stack, sorry, maybe we should take the first layer and sort of double click on it and look at it. So the first layer, Hari, you mentioned data. Data is really now fueling, pretty much all of AI, all of enterprise needs, and all of the outcomes that AI is supposed to drive. What are the key considerations that enterprises should take care when they're actually crafting this layer, inside the enterprise tech stack for data, which is either structured, unstructured, or whatever kinds?
The world of architecture and data management has just exploded. And the data lake approach to managing enterprise data, where both structured and unstructured data come together for various needs, is literally becoming the fastest growing enterprise application or enterprise technology that most people are adopting towards. In the past, enterprises would actually try to look at their data requirements into different buckets, right? They would segregate it. First one, they would say, oh, wait, these are my transactional systems. I'm going to have to keep them separate. This is my reporting layer, and I need a separate structure for that. And then they would look at AI applications as a bit of a standalone. Those worlds are increasingly converging, Ranjit. I know many companies have legacy investments in the first two, where it's transactional data and reporting layers. But increasingly, the way in which you actually have all of that data integrated and made available for AI is forcing organizations to take this integrated approach. So for me, many companies are now moving from on-prem capacity for data storage and compute to cloud computing. And the architectural evolution that we see with Delta Lake architecture is only going to get faster and faster with more migration into the cloud. Whether it's open source technology or proprietary technologies, I think we're going to see a massive explosion in how data gets to be managed. Historically, most of this data stored by enterprises were actually kept in silos. For example, if you're in finance, you had all of your finance data available in one place. In fact, they would even call it the finance data warehouse. And then you would
Correct.
have the manufacturing
Correct.
data warehouse. And they would take pride in saying, any data that you want, you can actually twist it like a Rubik's Cube and get the answer. Yeah, but what if I want to link something in the finance data warehouse with the manufacturing data warehouse? Thou shall not cross that thread line. So those kinds of paradigms are actually fast becoming outdated. And the ability for these new age architectures to kind of cut across those lines and give you the data that you need and make them available for AI applications is fast making this world very dynamic. So I'm pretty excited about this, and we'll speak a lot more, but hopefully that gives you a bit of a starting point.
No, I mean, this topic is a very large one, but I think you sort of summarized it very well for us. Um, so we spoke about data at rest, right? And we
Yeah.
spoke about a variety of things about it. we have to talk a little bit about data movement as well, right? So when it comes to moving data around, what are the mechanisms? What plays out in AI? Please give us a view.
Again, most of you that have been in this space for as long as Rajat and I have been in, you will recognize that, hey, the ETL would actually start according to the time zone of your company, and then it would actually be when most of your users were asleep, and then be completed before they wake up in the morning. And then you would have all of these batch processing stories to tell, war rooms to actually conduct when things went south and all that stuff, right? And interestingly, what's happening now is those environments are quickly converging into, hold on, I can no longer wait for a batch processing mode to move all of that data from my transactional data sources into a centralized warehouse. I need much more scalable environments. So in the past, where systems like Kafka would produce highly scalable environments, today we're actually finding more migration towards stream sets where you have much more ability to handle the transformation part of it along with the load seamlessly. And these new age technologies like stream sets, again, I'm not taking anything away from Kafka. I've spent a lot of time building warehouses using Kafka, and I love that technology to bits. But with stream sets, I have the ability to natively integrate with Spark or MLflow and the Delta Lake. And we find that level of scalability just super easy to deploy in large scale applications. So what we are starting to see is the technologies available in the space are just exploding on a monthly basis. You've got Airflow, you've got Jenkins. We particularly have a familiarity with Databricks, so we use the native workflows there to move data built on stream sets. But all of these technologies come with very unique capabilities, man. There is no right answer. You can leverage a combination of these tools. We'll talk a bit about open source versus proprietary stack in a bit, but you can't really go wrong with your choices. They may be slightly suboptimal, but the technology is evolving fast.
So is there, does any of in the data movement, depending on whether you want to move data fast in terms of real time versus batch mode, does anything change in this tool set choice or in the frameworks that you choose? Anything of interest?
Regardless of what tech stack you pull together, what technology you choose, you have to have pipelines that can support real-time transmission of data, right? You will always have some use cases that will need it. For example, if you're a retail organization and your interface into your customers is via your website, you're always going to need real-time updates on inventory. You can never get away from that. Trends on
Absolutely.
what customers are shopping for, trends on what likes and dislikes are, and all of that stuff can come on a batch processing board. But there will always be a certain percentage of your use cases that rely on real-time data. So you have to have pipelines that cater to real-time processing. You have to have pipelines that handle much more traditional batch processing. Now, traditional batch processing used to be on a daily basis. Now we're talking 30-minute batches, 60-minute batches, some even 3-minute batches.
So fascinating, Hari. So we spoke about data storage. We spoke about data silos and sort of breaking them down. We spoke about data movement. Then we spoke about the real time and the speed of data movement, how it's actually affecting some of the infrastructure, and also how to actually thread that back into the business outcomes. So great. So we covered the first layer of the stack, which is data. So now sort of floating upwards into the application layer. Um, Before somebody actually takes all this data and then starts throwing Python code at it and starts getting down into it, how should they approach this?
What we really need to think about from a tech stack perspective is we need a bit of a proper structured approach to not just writing or finding the algorithm, but knowing how that algorithm is going to perform in real time. So you need to kind of know what the end state is going to look like before you get to what algorithm you choose. And this is where frameworks in machine learning can really, really, really help you with a big head start, right? We'll talk about a few frameworks in a bit, but when you think of framework, it'll actually come down to what kind of programming language are you really comfortable with? For the most people, it's Python today. There are still aficionados that work with R, like me. I started off learning in R, so I'm going to change that. But it also means you have to start thinking about, are you comfortable with proprietary stack or are you more comfortable with open source stacks? My choice of poison is open source because I've just found the flexibility to be massive, but that's up to you. The third one is also level of community support, because regardless of what kind of best experts you can actually afford to hire, you're always going to need additional help in creating your ML applications, which means You need to have a community around your framework that can tell you, hey, I'm stuck in this place and I'm not getting the right answer. So think Stack Overflow, how much support is actually there for what your choice of poison is in some of these areas. So choosing the right AI ML framework will have to depend on what is the programming language you're comfortable with. Are you an prop stack or an open source kind of a tech stack in your organization? And how much support you have for that particular framework? And how much do you see continuous innovation happening in these frameworks?
No, no, perfect. We hear you. And so interestingly, Girish that time he was with Cruise. I mean, he spoke about something very similar to what you said, which is when you choose a framework, look for collaborators in that community. Make sure you actually have enough people who you can actually very quickly, bounce ideas off. So that's a great point, right? I mean, many of us actually tend to, don't pay attention to this, but having a community can actually significantly accelerate a lot of problem solving, and actually maybe many people have answers before you even have problems. The same area, frameworks, um, classical AI versus Gen AI. Does anything change in this layer, or is the approach the same?
What's happening in this space is we start to see TensorFlow and PyTorch starting to incorporate transformer models, right? But I'm also seeing significant upgrades coming in from Hugging Face or Keras and LangChain, where not only are they handling transformer-like models, which you see in GPT, but they're also coping with GANs. They're also doing pretty well with variational autoencoders. So the whole landscape of frameworks is evolving rapidly. Now, one common concern that comes up in a practitioner's mind is, hold on, I've already invested a lot in PyTorch. Now, does this mean that TensorFlow comes in with a
Correct.
much more
Correct.
newer version next week and I need to migrate into TensorFlow? Now, there are two things happening here. One, first of all, both PyTorch and TensorFlow have a phenomenal community around it. So the upgrades are keeping pace with each other. But the other thing that they both are doing are interoperability with each other. So it's not a significantly difficult task for you to develop something in TensorFlow and then actually deploy it elsewhere. So for me, the choice of framework is much more to do with the philosophy. Just because you've chosen one doesn't mean you're actually stuck on that forever. Or just because you've chosen one, it doesn't mean that you don't get enough upgrades. Choose the right one and you will constantly get the right upgrades. So for me, the choice of framework is an important one, but don't beat yourself about it.
Cool. So what you're saying is make a choice, be flexible about it, and see whether you can actually integrate different elements of the frameworks together, because they're all evolving at a decent pace. And you're also saying, most importantly, choose something that's actually having a high level of community support, so that these changes are constantly working at the same levels of updates across the frameworks that are in your view. Cool. This is really very useful. So we've got our data stack, we've got data movement, we've got the framework. So what's next? I mean, we just go ahead, build these models out and then churn them out and just throw them out to the real world, or how do things work?
Yeah. It feels like the first day for sure for Rajini movie, right? It's like I've got everything ready. I just need to actually see தலைவர் in action. But sorry, much more of a South Indian joke for those of you that actually get it. But the point I'm trying to make is almost everything that you've been working on seems like for this one moment, right? First of all, please take that feeling away. Developing models is one important step, nothing less, but it's only one step in the entire value chain. So in the energy industry, they would obviously say, "Hey, we are all about processing liquid gold." Your models will essentially be processing digital gold, which is your data. So this is what been setting yourself up for, and models is obviously the next step in it. We'll come to that in a second, but I think, Ranjit, one of the most important things we have to talk about is the question that almost everyone asks: do I actually go build or buy something off the shelf, or pick something off the shelf in open source, or do I actually go build something completely off the scratch? Um, there are a number of pre-trained solutions. Whether you actually have proprietary applications, if you have a Salesforce application for managing your CRM data, Salesforce has a number of native algorithms that are already available with them, right? If you have SAP, they claim to have a lot of algorithms. So there's a lot of these algorithms that are already curated for the environment that you're operating in that you could easily take up and then start exploring to get value. Unless you're a very unlucky person that's working in an industry where there is no pre-trained model, you're going to struggle. Unless you're that person, you really shouldn't look to go build on your own. Because the whole intent behind these pre-trained models is that they give you a heads up. When you're starting your journey, you want to take all the help you can get. There are some obvious disadvantages to using pre-trained models, but let's start with the advantages. First of all, someone's already thought about your industry, your particular use case. Someone already has a very good idea of what kind of data is needed to run those kinds of models. Someone's already done the hard work of kind of weeding out various data sources and applying different types of models to say, out of these 10 models, these four work the best. And I've already achieved a certain level of precision, accuracy, or speed and reliability with those models. So you've got a lot going in these. Now, the challenges are also there with pre-trained models. Some of these models are trained with curated data sets. Or, for example, if you're in an industry where the norm is to have brilliantly high quality data, all of these models are actually expecting great data. And if you're the poor sort that's actually having to deal with bad data in your enterprise, then you're really out of luck. But except for those rare occasions, these pre-trained models should really be able to help you get off the ground without much of a fuss. Now, once you've kind of built your capability in this space, know how to operate the entire tech stack, know how to actually deploy these models in production and so on, you can start thinking about building your own models. But if you're new to the space, please start with something that's available. And there's so many sources, right? Like I said, enterprise software already has pre-built models. You can get open source models from different sources in the marketplace. Even Kaggle and Hugging Face can actually give you or expose you to some of these models that you need. So explore all options that can give you these pre-trained models rather than try and build them on your own.
So if somebody was to actually, pick a pre-trained model for like a manufacturing or retail, for a particular use case, versus going out there and building their own, how much time do you think they're typically solving by choosing a pre-trained model? Any guesstimate that you have in your head?
Um, Again, I'm not going to try and actually put out industry figures. I'm going to use my own experience to kind of put a bit of perspective, right? So when we started building churn models for predicting when a customer is going to leave us, won't get into the business details, but it was it was a very particular kind of a retail industry, physical retail. It was not digital retail, and we had to figure out when a customer with significant volumes would start to kind of give us indications, right? Um, there's the basic models for churn that you can actually look at from a large number of prepackaged solutions. We didn't go down that model. We started building our own churn models. We said, hey, we think we can actually get a regression model out there. We think we can actually start to use various statistical models to predict when a particular customer is going to churn. We spent about 4.5 months building a churn model that would possibly give us maybe 60, 70% accuracy. But eventually, what it turned out to be was there were prepackaged churn models in one of the softwares that we were using that actually gave us 55% accuracy right from the get go. Now, I
Okay.
spent 4.5 months trying to get that 10% boost. And if you know churn and if you know the retail industry, that 10% doesn't actually mean anything. So I'm just using that one use case. Now, I've learned from that mistake, and I always look for pre-trained models in a number of these cases. But I also know for a fact that a pre-trained model will come with some of the disadvantages I spoke about earlier, and I watch out, right? I generally do my due diligence to say, hey, what was this model trained on? Is the data comparable? Is the environment and the context comparable? Will this really solve the problem I'm looking to solve for my particular industry and context? So, except for those watchouts, you should be able to accelerate your journey way more with pre-trained models,
No,
especially
no,
for common use cases.
sure. Thanks for sharing that and the transparency on, on sharing, how you approach that as well. I think there are so many models out there and they're all changing at the speed of light, if you may call it that. There are, of course, very specialized use cases in healthcare, life sciences, maybe legal, I think, where you have to pay a lot more attention to the IP and the risks and compliance. So maybe those industries, people have to pay a little more, a little more attention. Some of the more generic is you're saying from whatever you're saying. Is it really worth the extra accuracy before you invest that few weeks or few months to actually even develop your own model? Ask yourself that question, is what you're saying. Once somebody's got a model in place, I think the next thing that they're thinking about is obviously deploying a model and getting it out there so that it can actually start serving things into the real world, which is always a favorite topic, DevOps and SysOps and everything else. How do you think somebody should think about this?
when you're thinking about your model, it doesn't actually go into deployment in isolation. You essentially start with how do I extract the data that's needed? How do I actually make the data available for a training period? How do I kind of get to that information, insights, and validate it? And then, okay, now I've got a model that works. And then how do I actually deploy it in runtime where the needs are entirely different, right? I mean, for training, I have large volumes of data to make sure that I get the model really right. But once the data is available for training and it's done, I don't need that anymore. On production, I need much smaller sets of data. And then, of course, it's going to run at higher levels of efficiency from a technology standpoint. So the whole DevOps or SysOps and the ML Ops part of this entire structure is about I've got my data in the data storage and the data layer. And then I've got to put that out into my compute layer, structure it between training, validation, and then deployment into production. But then there's also a layer around, okay, when the data starts to drift, I need to make sure that I actually account for the data drift, or when my model starts to drift, I account for my model drift. But it starts to give you that comprehensive picture around how do you keep this up and running for business value? Because ultimately, it's all about that business value. So the entire focus is not just about getting that model right one time, but is to go fit it into that entire value chain that allows you to say, I've got the data coming in this periodicity and this level of volatility, and I can now start running this algorithm in production and give this level of insights into the next part of the value chain. So DevOps is about making sure that that value chain is running smoothly and you have the ability to kind of manage that and govern that as you go through the organization.
Super. So you're saying look at it as a pipeline, like in a
Yes.
factory, and look at it as how to keep that pipeline moving, how to keep things smooth. And that's what's determining your choices because everything is changing all the time. As you rightly said,
Exactly.
data that's coming in, the model accuracy, the model validation, the business feedback coming in on the models and their accuracy, maybe customers even coming in. Super. So there's another buzzword, right, which is actually which people love to talk about, and of course, rightly so, containerization. So, what is the place of containerization in all this? And how does that actually add value to this?
So before that, right, I want to kind of build the link from containerization to the application layer. Now, Kubernetes started off as an internal Google application, and what it allows you to do is basically take all that you need to run some of these new age technologies into a real nice containerized a virtual container. And then it lets you kind of deploy it at pace across a number of use cases within the enterprise. The application layer is where the containerization magic works, ensuring that we are able to deliver the ML insights, the AI ML insights into the hands of our users is the most important last mile connectivity when it comes to this value chain. Ultimately, the user doesn't care about the fancy tech that you've deployed behind the scenes, but you
Absolutely.
need to make sure that it gets containerized, delivered to you in a packaged form that tells you this customer is about to leave your organization. Why don't you come up with this particular offer so that you can retain them for the next 6 months and then continue to increase your profitability of the portfolio? So that last mile connectivity where AI ML adds value is one of the most important steps. The way in which this beauty has evolved over the last few years, if you really have a perfect word, the containerization and your application layer can actually be independent of everything that happened before that. Now, it's a utopian world.
Fascinating. I mean, honestly, I think we covered very large section of of the framework that we want to sort of get out there. And I think you very beautifully touched upon it on what containerization will really help doing and packaging and bringing it out. Um, Now, coming to a favorite topic, in enterprise management, right? I mean, anything in an enterprise has to be governed, right? And an AI infrastructure is going to be no different. And without this, obviously, nobody is going to really buy into to the value of AI unless they can actually figure out how they can actually put in checks and balances, controls into this. How does one explode this stack, and how does one sort of make sense of this so that it becomes generation generating value to the management is as important, and this layer sort of does that for the management. So how can they actually plug into this?
That actually triggers a bit of a mixed reaction from the technical community. And the reason for that is there's two there's two types of governance. One is the technology governance, right? So whether it's data governance and the Unity catalog in Databricks, or whether it is the ML ops governance within the ML frameworks that you have, technologists get super excited about, hey, I can actually show you exactly where the data goes from here to here. I can actually show you traceability in the model. And there's a lot of technological governance, sorry, innovation in the governance for the technology itself and the data. But there's another side to the governance angle, right? The enterprise governance, right? The programmatic
Absolutely.
governance on how do you manage cost, how do you manage use cases, how do you manage politics and all of that stuff. And that side triggers a bit of an allergic reaction. It's like, I'm a technologist, just let me do my job. I don't want to be in all of that
Yes.
nightmare. But unfortunately, I think those two go hand in hand. The technical stack governance is evolving equally in step with the technology. And some of the stuff I've seen, whether it is model traceability and observability or explainability, some of the explainable AI frameworks that I've actually seen coming through in the last few years, it's just been incredible. There's a lot more work to do, but it is so much more than saying AI is a black box today. You're able to go in and say these are the features that contributed to the end results, and is able to let you tweak the AI itself. But the programmatic governance is something that technologists have to really go through. You really need to understand that at the end of the day, the enterprise is making an investment in a technology expecting a certain set of returns. And unless they are able to see those returns come through, those investments are going to dry up. We would do that in our own normal life. If we're building up a small kitty for some good purpose, we would constantly put money in. And then when the returns don't come in the way we expected, we then move it to another investment. Why should an
Absolutely.
enterprise be any different? So for me, that's how I would actually look at the governance versus the cost and scalability angle. It's not sufficient if you get excited by technology and then get the best of the technology deployed at your organization. It needs to be in step with the cost and the value aspirations of the organization, and making sure that you kind of constantly link it back and forth to say, I'm making this choice. Does it align with the cost expectations and the value expectations? And does it deliver on the value expectations of the organization? Is something I would say is very, very critical.
Super. So, one other aspect, right, that comes up in typically most of the enterprise, governance rooms is vendor lock-in, right? And if they're putting in, thousands of dollars, and how does one approach this? Is it very different from how you approach it for other parts of the digital ecosystem, or is AI the same? How do you approach vendor lock-in?
If you've been patiently listening to this podcast till now, you obviously know by this point how much of an aficionado I am of the open source ecosystem. So vendor lock-ins are a bit of a risk in my head at any given point in time. But that doesn't mean vendors aren't going to help us, man. I mean, look, some of these technology companies, let's take cloud. Unless you're living under a rock, you have some form of cloud deployment in your organization. You mostly have a mix of cloud and on-prem, both compute as well as storage. And you have powerful cloud ecosystems that you're a part of, whether it's Google, Azure, AWS. They offer incredible flexibility. So there is no questions that vendors are going to be an integral part of your tech stack. But what is important is always bear in mind that technology is evolving incredibly rapidly. I mean, Moore's law is getting common at the pace at which technology is developing, right?
Right.
For me, having a tech stack that is agile, where I can quickly swap in and out technological components that allows me to be more up to date is critical. You almost start to touch upon concepts of modularity,
Correct.
where if you don't like a particular ML framework, you take it out, put something in quickly. The
Right.
cost of doing that swap has to be minimal. You can't have an enterprise stack where the cost of moving from one technology to another is so prohibitive that you're just stuck there. That's the part that you need to avoid. So when you're crafting your tech stack, make sure that you're constantly looking at, if I swap this out and then put something in, how expensive will it be? Now, let me be very clear. I'm not expecting it to be as cheap as just pulling out a battery and then replacing it with a new one. It's not going to be that cheap or that simple, but make sure that you minimize that angle very, 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 very heavily. Because as you go on the AI ML journey, you will constantly get the feeling that something you've deployed today will get outdated next week. And you're wondering, should I waited for another week to deploy? No. The answer is always a no. But protect yourself by making sure you construct your entire tech stack in a modular fashion that allows you to swap out something. You keep learning on the current platform, and once you've mastered it and you waited for the other one to mature, swap this one out with minimal cost and inconvenience to the organization.
Super. So, Hari, we sadly come to the end of this episode, but it's been incredibly insightful. And what would you like to give as your closing comments? What are the top things that an enterprise should keep in their mind when they're crafting the enterprise AI stack?
Start with your business goals and really get the business involved in the journey. Uh, Start with the end in mind. You need to know where you want to deploy your AI so that you can construct your tech stack upwards from there, and make sure that your tech stack is built in a modular fashion. There will always be times where you'll get some of these decisions wrong. Your small decisions, getting them wrong is not a bad deal. You learn from them. Be open to experimentation and flexibility. That will save you a lot in the long run. And most importantly, pay a lot of attention to data, governance, and cost throughout the journey.
Super. So thank you again, Hari. Really, really insightful. I'm sure our listeners are going to find digital gold in this podcast. I surely did. Look forward to having you on board for future podcasts, and we have many topics to talk about. Thank you again, and
Hope you enjoyed this episode of the Neural Talks. Hit subscribe or follow us on LinkedIn to stay informed of many more great episodes on AI coming up. We're the Neural, where humans meet AI.